Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to continue writing the CSI plugin that we have been writing in some of the previous videos. So let's go ahead and try to briefly look into the things that we have already achieved. So let's say this is the Kubernetes cluster that we have, and what we were able to achieve is we were able to discuss about all the things. For example, what CSI specification is, what are CSI sidecar containers, how do we actually write a very dummy CSI plugin structure, and then how do we deploy it on top of Kubernetes. So we were able to deploy our CSI plugin as a pod in Kubernetes cluster with a CSI sidecar container, and this container was external provisioner, and external provisioner listens to PVC resources in the Kubernetes cluster, and as soon as external provisioner figures out that a PVC was created, it calls respective RPC from our controller plugin, and then controller plugin actually calls storage provider specific APIs to actually provision the volume. So all these things have already been implemented in the previous video. If you have not seen them, I highly recommend you should watch those videos. So now that we know, as soon as a PVC was created in the cluster, our CSI plugin, with the help of CSI sidecar container called external provisioner, is going to call create volume RPC from the controller plugin, and this controller plugin is eventually going to call, let's say, storage providers APIs to provision the volume. And once the volume is provisioned, once controller plugin responds back saying that the volume has been provisioned, this external provisioner creates a PV resource, persistent volume resource, in Kubernetes cluster to specify the volume that was created in the storage provider. So once persistent volume has been created in the cluster, and if we try to mount or use this persistent volume in a particular workload, let's say a pod, in that case attach-detach controller is going to create another Kubernetes resource called volume attachment, and this volume attachment resource actually specifies, or it actually has details about which particular volume should be mounted on which particular node, because obviously there are chances that you have n number of nodes in your Kubernetes cluster. So in that case, based on some parameters, attach detach controller is going to create a volume attachment resource, and this volume attachment resource has details about which particular volume ID should be mounted on which particular node. Now, if a volume was created on a storage provider, and after creation of volume attachment resource, that volume must be mounted on a particular node, it simply means that after creation of volume attachment resource, there should be something like, if you see here, we had external provisioner. Similarly, there should be another sidecar container that listens on volume attachment resources, and as soon as a volume attachment resource is created, this sidecar container is going to call another RPC of controller plugin, and that RPC of controller plugin is going to mount the volume that was created to a specific node, or to a specific node that was specified in this volume attachment resource. So let me try to summarize this once again. Once create volume request was called from external provisioner, the controller plugin is actually going to create the volume by calling the storage provider APIs, and once create volume request was successful, the external provisioner is going to create a persistent volume resource to denote or to specify the volume that was created on storage provider. If we try to mount that volume, or if we try to use that volume inside a workload, in that case attach detach controller is going to create a volume attachment resource, And as soon as a volume attachment resource is created, there should be another sidecar that watches for this particular resource and then calls the specific RPC from controller plugin that attaches the created volume to a specific node. Now, to figure out which particular RPC should be called to attach the volume to a specific node, I recommend you to watch the previous videos because I have covered that in a lot more detail in the previous videos. Now, let's go ahead. The things that we have already covered is we have deployed this pod with external provisioner and the controller plugin. Now, if you see here, we are also going to deploy the external attacher. So this sidecar that we are talking about here, this sidecar is called external attacher. So now in the same pod, we are going to deploy external attacher sidecar, and that external attacher sidecar is going to by default going to watch on volume attachment resources, and then it's going to call controller publish volume RPC of controller plugin, and that RPC should be able to attach the volume to the node. So I already have a Kubernetes 3-node Kubernetes cluster up and running. This is a kubeadm setup Kubernetes cluster, so we should not have any storage class. We should not have anything extra in this particular cluster. So let's go ahead, and what I'm going to do is I am going to open our source code repo. So if I try to show you, this is where our GitHub repo is. This entire code base is pushed into that GitHub repo. If you want to check that out, you should check that out. And let me just go ahead and try to open the source code. So this is the thing that we have already implemented in the previous video. So again, if you are not very familiar with this particular code, I highly recommend you to go check that out. So now let's just go ahead and try to go into controller.go, and in controller.go there is this RPC called controller publish volume, and this controller publish volume is the RPC that gets called as soon as a volume attachment resource is created. So let's just go ahead and try to log something here. So fmt.println, and then controller publish volume of controller plugin was called, and let's just go ahead and try to deploy everything. So go build. This is going to build a new binary, and again, if you are not very sure about how Docker file is written, etc., I highly recommend you to check previous videos out. Again, this Docker file can be improved, but I'm just using this for now. So docker build -t Vivek saying GZIDS. Let's see how we have named our image. So it's this. So we are going to change the tag now to 9 and build the image. As soon as the image is built, we are going to push it. And once the image has been pushed, we are going to change the tag in the manifest that we have. Okay, I will also have to make sure that this secret is correct. So because this is the secret that is going to get used to call the storage provider, in our case is DigitalOcean, to call DigitalOcean APIs. So I will have to make sure that this access token is correct. So let me quickly try to do that. So yeah, you can anyway, I think base 64 decode it, but I'm gonna change it anyway. So let's go ahead and try to list everything from default namespace and create all the manifests that we have created. So if you see here, it creates a cluster role. It also creates a cluster role binding. It creates a service account, deployment, storage class, and secret. Now, let's look at the logs from this pod, and let's go ahead and try to create a volume and a pod that tries to use that volume. So create -f manifests and tests. If you see here, inside tests we have a pod, a very simple PVC resource, and this PVC actually uses the storage class that we have created just now by this particular manifest. And this PVC, after this PVC is created, we try to create a pod that tries to use that PVC. So let's just go ahead and try to create that. So now if you see here, it clearly says that the volume was successfully provisioned in the DigitalOcean. And if we go ahead and try to look into DigitalOcean console for volumes, we should be able to see a volume here in the console. If you see here, this volume was created just now. And again, if you see, we do not see that controller publish volume of the controller plugin was called. And the reason is, again, if we go back to this particular example or diagram, external provisioner, let's look into the manifest once again. So if you see here, this external provisioner actually just listens for PVC resources and then calls create volume RPC. So to make sure that volume attachment resources are also watched and then controller publish RPC is called, we will have to deploy another sidecar called external attacher. So let's go ahead and first try to verify that a volume attachment resource was created. And if you see here, we can clearly see the volume attachment resource was created, and this specifies the volume ID and node relation. So now let's go ahead and try to change this manifest to include CSI attacher as well. So to figure out the details about CSI attacher, what you can do is you can go ahead and try to look into this particular GitHub repo, Kubernetes-CSI/external attacher. And if you see here, the main things that this particular component needs is CSI address to figure out where exactly or which domain socket our CSI plugin server is running at, so that external attacher can call the specific RPC using gRPC. So this is the main thing that we have to specify here. And we can refer the exact same thing that we have here. So the image is going to be, let's go to releases, and we can use this image here. So image is going to be CSI attacher. The name is going to be CSI hyphen, or let's say external hyphen attacher. And we will also have to specify args, because if we look at the readme once again, it simply says that these are some of the command line options, and CSI address is actually the required one, and it says this is the path to the CSI driver socket inside the pod that the external attacher container will use to issue CSI operations. By CSI operations, it simply means that once a volume attachment resource is created, it is going to call ControllerPublishVolume RPC of the gRPC server. So now
first, use face recognition to unlock the
sorry about that. So yeah, first what we will have to do is we will have to mount the volume, this volume that we have specified here, because this is the volume where that is mounted in the main container. If you see here, this is the same volume that is mounted in the main container, and that is where the gRPC server is running. Again, I have talked about this manifest in previous videos, so I highly recommend you checking that out, and that way things are going to make much more sense. So let's go ahead and try to mount the volumes like we have mounted for this another container, and we are going to call it, we want to mount the volume called domain-socket, and we want to mount it at this particular location. And we are also going to specify environment variables, and the name is going to be CSI endpoint, and the value is going to be, this value is going to specify where exactly this particular container is going to look for the Unix domain socket where gRPC server is running. So this is going to be this path, and then CSI dot sock, because this is the location where our main container runs the gRPC server for the controller plugin, or for controller and node plugin both. Once we have set the environment variable, we are going to set the argument, and we know the argument that external attacher expects, and this is the argument. So equals to, and CSI endpoint. And once we have set the CSI address, I think things should work now. So again, if I try to summarize this once again, if you see here, we were able to get a volume attachment resource, and external attacher is going to make sure that once a volume attachment resource is created, this external attacher is going to call controller publish RPC, controller publish volume RPC of the controller plugin, and it would be able to call that because the Unix domain socket where the gRPC server is running at is shared between all the containers of this pod. So let's go ahead and try to build this once again. Once the binary is built, I'm building and pushing the container image, and once it has been pushed, we are going to change the tag here, and we should be good. But before that, let's delete the PVC and the pod that we created to do the earlier test. I'm trying to delete the PVC and everything manually, just so that we won't have any conflict or anything. Okay. There seems to be a problem in the deployment spec. So it says error validating data, deployment spec template containers 1 dot env0 values. So it should be value, not values. So now if you see here, earlier there were two containers, but now we see three containers because now it has external attacher as well. And let's look into the logs of all the containers here, and let's go ahead and try to create the PVC and pod once again. So again, if you see here, as soon as we added the CSI attacher sidecar container, we started seeing a problem, and that says BSOS service account doesn't have list permission on CSI nodes resources. So let's go ahead and try to do this. So we are using this new service account called BSOS-SA, and this has all these permissions that are specified here. So we have to give permission to list CSI nodes resources. So list and CSI nodes. So if you see here, we are eventually going to give list and watch, so you can fine tune this. But yeah, I mean, if you know RBAC, you would be able to make this manifest better. So once we have done this, let's go ahead and try to create everything once again. So apply -f manifests, and I'm going to delete the pod manually just to make sure that the new cluster rule is applied. Okay, so now if you see here, CSI attacher has also been started. So now what we are going to do is we are going to create the PVC and a pod that tries to consume that PVC. So create -f manifests and tests. And now if you see, task pod was created, but if we look into the logs, we are able to see that the the volume was provisioned successfully by the CSI plugin, but we still do not see controller publish volume of controller plugin was called, and also we also are not very sure if CSI attacher was even able to call controller publish volume or not. So to resolve this, what we are going to do is let's try to change verbosity for this new attacher that we have, new component that we have added. So I think it's -v, but let's go ahead and try to. So if you see here, -v can be specified. So -v equals to 5, and let's try to run this once again. I'm just trying to delete previously created PVCs and PVs, etc. Okay, so now we will have to apply the manifests once again, and then we are going to see if we are able to see any extra logs for the in the CSI attacher or not. And let's go ahead and try to create the PVC and pod to consume that PVC once again. So if you see here, it clearly says that the volume was provisioned successfully, and immediately after that it says that started volume attachment processing. So CSI attacher was able to figure out that a volume attachment resource was created, named this particular volume attachment resource, and it started processing that particular volume attachment resource. So if I just try to go ahead and list volume attachment resources called this, we should be able to see that volume attachment resource. And once it started processing that volume attachment resource, we see some error logs, we see some logs. It says attaching, it also says started attach operation, and then it also says other, yeah, it logs other details. And after some line we see here can't get node id from CSI node, and this particular CSI node. So if you read this particular error message clearly, it simply says that it was not able to figure out node id from CSI node object. And the reason is our plugin is not actually registered with the kubelet. That is the reason kubelet was not able to update the CSI node resource to specify all the details. So let's just go ahead and try to very briefly look into the CSI node resource. So kubectl get CSI node. Usually we would get a CSI node resource per Kubernetes node in the Kubernetes cluster. And if we try to, let's say, get a CSI node resource, if you see here in specification, we do not see anything, and it simply means that maybe Kubelet created this CSI node resource, but it has not been updated by the CSI plugin that is running on the Kubernetes cluster, because it's plugin's responsibility to make sure that this particular CSI node resource is updated with the correct details, let's say, or with correct information. So now to make sure that CSI CSI node is updated with the correct details, we will have to make sure that our plugin is registered with the kubelet that is running on the Kubernetes cluster on all the nodes. And that is the reason we would have to use another CSI sidecar container that we are going to look into in just a bit. But before that, let's very briefly talk about CSI node. So if you see here, it holds information about all CSI drivers that are installed on a node. So obviously there are chances that there are more than one CSI plugins that are installed in a node, and this CSI node or CSI node resource for that specific Kubernetes node is going to have all the details about, or some details about, all the CSI plugins that are installed. So if you see here, CSI drivers do not need to create CSI node object directly, because like I said, there are chances that, or not chances, but in most of the cases, Kubelet is going to create these resources. As long as they use the node-driver-registrar sidecar container, the kubelet will automatically populate the CSI node object for the CSI driver as part of kubelet plugin registration. So what happens is, like the sidecar containers that we have been talking about, there is this other sidecar container called node-driver-registrar, and this sidecar container, the whole responsibility of this sidecar container is to make sure that it calls a specific RPC called NodeGetInfo from node plugin, and then registers the CSI plugin with kubelet using the information that was returned from NodeGetInfo. So again, if I try to, let me quickly go ahead and try to summarize this. So what happens is, let's say this is the controller plugin that was running, in the cluster, and then we will also have to run node plugin. And again, we have already talked about this. Node plugin must run on all the Kubernetes nodes. That is the reason we should run this as a daemon set. And this node plugin is going to have a sidecar called node driver, sorry about my handwriting, node driver registrar. And node driver registrar is going to register this CSI plugin with the kubelet. Let's say there is this kubelet that is running on this particular node. So node driver registrar is going to register this CSI plugin with kubelet by or with the information that it gets from CSI plugin by calling NodeGetInfo. So this is how node driver registrar registers a CSI plugin with kubelet. And that is the reason we will have to make sure that node plugin is running on all the nodes. And that is the reason we will have to run node plugin as Daemonset. And NodeGetInfo is actually an RPC of node service. That is the reason now we will have to deploy node plugin as well. So let's just go ahead and try to create a manifest called node-plugin.yaml, and we are going to copy Daemonset. We are going to copy Daemonset manifest, example Daemonset manifest from Kubernetes docs. And let's just go ahead and copy this here. We want to name it node-plugin. I'm not going to specify namespace or labels. In spec, we are going to specify the selector to be node-plugin, and that is the reason this label is also going to be node-plugin. We do not want to specify any tolerations for now. And this is going to be the place where we are going to specify all the containers for our node plugin. So our main container, let's name it node or node plugin, and the image is going to be the same image because the architecture that we have chosen is both the RPCs, both set of RPCs for controller plugin and node plugin are implemented in the same binary, and we are going to run the same binary in node plugin or controller plugin. So we are going to use the same image that we are using here, and we are not going to specify resources for now, just to make sure that things are working with minimum efforts. And we are going to specify the volume, and we are going to specify the volume and volume mounts in just a bit. But before that, let's go ahead and try to look into the CSI node driver registrar sidecar. So I hope this makes sense up until now. If you have any question about this, don't hesitate to reach out to me. So if you see here, again, we have already discussed about the responsibility of node driver registrar. The main responsibility, if you see here, this is necessary because Kubelet is responsible for issuing CSI node get info, node stays volume, node publish. The node driver registrar registers your CSI driver with the kubelet so that it knows which Unix domain socket to issue the CSI calls on. So again, kubelet is going to call all these RPCs that are node stays, node publish, etc. That is the reason kubelet must know where these RPCs are implemented, and that is the reason node driver registrar is going to register our plugin with the kubelet. And if you see here, it says there are two sockets that this node driver registrar requires. One is registration socket. So if you see here, we have to mount the domain socket where our plugin is running at, and we have to mount that inside the container at /registration path. This is standard. This is what we will have to do because this is how, let's say, CSI node driver registrar is written. It clearly says that the host path volume must be mounted at this particular location, and this is going to be the host path on your machine where the gRPC server is running at, and we are going to look into that in just a bit. And CSI driver socket, again, this is going to be the CSI driver or Unix domain socket where our gRPC server is running at. Again, you should be familiar with that now, because if you see here, we created empty dir volume here, but in this particular case of node plugin, we are going to create host path, but it's the same concept. We are trying to share the Unix domain socket between two containers. So let's go ahead, and if you see, these are the two required arguments that we are going to specify to the container, to the node driver registrar container. One is CSI address. It simply means that it specifies where exactly the CSI plugin, node plugin is running at, and then Kubelet registrar path actually specifies which particular location or how Kubelet can communicate with the CSI plugin. So this is the path to the CSI driver socket on the host node that Kubelet will use to issue CSI operations. And CSI address is the place where node driver registrar is going to use to issue the operations. So now let's go ahead, and I have seen an example here. So I'm going to use the exact same example. So we are going to create two volumes first. Node plugin, and we are going to create two volumes. So if you see, I'm also going to change it to directory or create. So registration directory is again the directory that is used to register a plugin with Kubelet. Again, you can try to read more about how a plugin can register itself with Kubelet, but this is the directory that can be used to do that. So that is the reason we are specifying this directory in host path, or we are using host path volume, and we are setting the path to be var lib kubelet and plugin registry. And we are going to also make sure that we are running our plugin at this particular location. So we are going to call it bsos.vbxing.dev. And once we have created this volume, we are going to specify this volume to our node plugin to make sure that our node plugin is running at this particular Unix domain socket. So let's go ahead and try to add this container. We are not going to need ports and liveness probe for now, because again, we are just trying to make the things work. And so we have node driver registrar. We are also specifying kube registration path. We are going to talk about this in just a bit, but let's first change this to vbxing.dev, and then plugin directory is going to be csi/csi. And if you see here, we have explicitly mentioned /registration, because in the readme itself we saw that this particular socket must be mounted at /registration, and that is the reason we are mounting this registration directory at /registration. And we are also going to specify or at this particular point in time, node driver registrar thinks that the CSI is running at /CSI. That is the reason we have specified /CSI/CSI.sock, because this is where our node plugin is going to run at. If I complete this, things are going to make much more sense. So let's mount the volumes here as well, and we are just going to specify the CSI endpoint where this node plugin should run at. So I'm going to mount the volume called plugin-dir, and we are going to mount it at /CSI, and we are going to set environment variable called name, and we are going to call it CSI endpoint, and the value is going to be Unix colon / CSI and CSI dot sock. I think things should make more sense now. So we have created two volumes. Let's just talk about plugin directory for now. So plugin directory is a host path volume in the host where that we want to mount in the node plugin so that Unix domain socket can be shared between the main container and the sidecar container. So this is the directory that we have created, let's say, in the host path, and that directory is mounted at this particular path, and then we are running this domain socket and eventually the node plugin at this particular location. And because the same volume is mounted in the sidecar container as well, if you see here, we are going to specify the CSI address to be /CSI/CSI.sock. I think this should make sense. And now if you see here, this is the directory where our CSI plugin is running at. That is the reason we have specified that for or as value of kubelet registration path, because this is the location that kubelet looks for to issue CSI commands. So I think we are good. Let's just go ahead and try to create everything once again. So again, we are going to delete the test manifests to make sure that things are not conflicting. So pod ---- or task ---- force ---- period 0, and we are also going to delete the PVC and PV as well. And let's delete volume attachment. Okay, so now that we have deleted everything, let's go ahead and try to deploy this entire thing once again. So now we should get our Daemonset object, and that Daemonset object is going to create two pods to run on two worker nodes that we have here. So if you see, we have one leader node and we have two worker nodes, and these are the two worker nodes where CSINode plugin is going to run at. So apply -f manifests, and if you see, we are seeing that two pods are coming up, and let's see logs of this particular pod. Okay, so it looks like there is a typo somewhere here. Okay, all right. So the problem is, if you see here, it says supported scheme is Unix, but provided this, it simply means that if you go ahead and try to look into driver.go, or this is where it's failing, and it looks like somehow URL is not being passed correctly. URL is being figured out from endpoint, and that is the reason I figured that we are not specifying arguments to our main container of the pod. So let's go ahead and try to do that. So args, and args is going to be ---- endpoint, and value of endpoint is going to be CSI endpoint. So now it should work. I am going to apply everything once again, or yeah, I was just thinking if we have to rebuild again, but I don't think we will have to rebuild because we have not changed the code. So now we see it's in container creating, and we see an error now. Okay, so yeah, if you see here, now it says it's trying to call running node driver registrar in the node in mode registration, starting registration server started, and skipping HTTP server because endpoint is set to empty. So if you see here, it says received get info call, and it simply means that NodeGetInfo RPC of the node plugin is not implemented. That is the reason we are getting into this particular problem, because again, if you remember, when we looked into this particular diagram, we said that node-driver-registrar is going to call this RPC from node plugin, and then it would register plugin with the kubelet. So let's go ahead and try to implement the NodeGetInfo RPC from the node plugin. So if you look into the response, this is how the response looks like. So we are going to specify node ID. We can also specify max volume per node. This would be known to someone who is writing plugin for their storage provider. I'm just going to specify 5 for now, and we are going to also specify which particular reason this volume would be accessible from. Since we are working on AMS3, so if you see here, we have specified default reason to be AMS3. That is the reason I'm going to specify the same thing here as well. So reason, and it's going to be AMS3. So now we have to somehow figure out node ID on which this particular node is running on. So we know that node plugin runs on every node, every worker node that is there, on the Kubernetes cluster. So let's go ahead and try to figure out the node ID. So if you look into this particular API reference, so by getting the metadata client, if you see, we can figure out the droplet ID where a particular code is running at, and we can use this particular SDK. So if you see, go client to interact with metadata API, and this is how we can use it. So let's go ahead and try to use this. So go metadata, I'm going to call it metadata, and this is how we can create a new client. So metadata dot new client, and I'm going to call it md client, and just to remove the compilation error, I'm going to print md client, and let's just go ahead and try to build this. So go build. It should fail because we don't have this module, and once the module has been downloaded, it should get built. And now what we are going to do is we are going to get droplet ID from this metadata client. So md client dot droplet ID, it returns, I think, droplet ID and error. So id colon error, and if error is not equals to nil, in that case we are going to return the response to be nil, and error is going to be status dot error codes dot internal, and then we are going to specify the message as well. So error getting node ID, and if we were able to figure out the ID successfully, we are going to specify the node ID for the value of field node ID. So string conv, and then we have to convert from number to string, so I to A and then ID. So now if we try to go ahead, rebuild everything and deploy it, we should be able to first of all make sure that CSINode resources are updated with correct drivers, and then node-driver-registrar sidecar should also be able to call NodeGetInfo successfully, and it should be able to register the plugin with the kubelet. So let's go ahead and try to do everything once again. So manifest test, and Okay, so it looks like we had not created the test manifests. Okay, so it looks like we have built the binary. Let's go ahead and build the Docker image, and once Docker image has been built, we are going to push it, and we will also change the we don't have to change controller plugin because we don't have any change in controller code, but let's just go ahead and change this as well. And this is also going to be 11, and let's go ahead and try to deploy everything once again. So apply -f manifests, and we should get all these pods created once again. So now as you see, Node plugin is also running successfully. Controller plugin is also running successfully. Let's go ahead and try to look into the logs of the controller plugin. Excuse me, all containers, and follow the logs. Similarly, let's go ahead and try to look into the logs of Node plugin. So kubectl get pods -- show labels. I'm trying to see the logs using labels so that I would be able to see logs of both these pods. So logs -l and name equals to node plugin, all containers, and then follow the log. So first of all, let's go ahead and try to look into the CSINode resources. Now if you see, both of these resources have been updated, and if we try to actually get the detail, we should be able to see, if you see here, we are able to see the name of the CSI plugin. We also see node ID of the node, and we also see the topology that we have specified in NodeGetInfo. If we try to get the same CSI, not CSI node, but the same resource with another value, we should be able to see another, if you see here, another node ID, because again, CSI node resource is created for separate nodes in Kubernetes cluster, and separate nodes would obviously have separate node IDs. Now let's go ahead and try to create the PVC and the pod. So create -f manifests and tests, and okay, so now it says started volume attachment processing, finalizer is ready. Attaching, node ID annotation added, saving attach error, failed to save attach error. This service account cannot patch resources this, and cannot patch resources volume attachments. So let's go ahead and try to add this role as well. So open cluster role, and then verbs is going to be patch, and we will have to add volume attachment resources, volume attachment and status sub resource, because we did see that it needs access to volume attachment / status as well. Now I don't see it somehow, so here we go. So volume attachment status, and now let's go ahead and try to deploy everything once again. But before that, let's delete the test thing. So delete -f manifest tests. Okay, so now I'm going to apply everything once again. So kubectl apply -f manifests, and cluster rule obviously would get updated, but just to again be on safer side, let's delete the pods to make sure that the cluster rule is actually reflected. So again, we are going to look for the logs in the controller plugin, and then we are also going to look for the logs in the node plugin. So now I'm going to create the PVC and the pod that consumes that PVC. So create -f manifests and tests, and let's see what happens. Okay, so if you see here, it clearly says that grpc call CSI.v1.controller publish volume, but somehow we do not see that. Yeah, if you see here, controller publish volume of controller plugin was called, so it simply means that once the volume attachment resource is created, now controller publish volume RPC of controller plugin is also being called. So this is it that I'm going to cover in this particular video. We are obviously going to implement controller publish volume in the next video, but if I try to do that in the same video, it's going to be very lengthy. So let's go ahead and try to summarize everything once again that we have talked about in this video. So let's say what we have done is, if we have this particular Kubernetes cluster, and if we create a PVC resource, we have a controller plugin. Again, I have talked about it already in previous videos. When we talk about CSI plugin has, let's say, two components, and those two components implement separate set of services or RPCs. There are some RPCs that are called controller RPCs or controller services. There are some RPCs that are called node services. So node plugin implements node RPCs, controller plugin implements controller RPCs. So this is controller plugin. This gets deployed as deployment, and it has two sidecars, one main container. This is external provisioner. This is external attacher. And as soon as a PVC resource is created, external provisioner is going to call create volume request from controller plugin. This is going to create a volume in the storage provider, and once this returns back with success, external provisioner is going to create a PV resource. And if we try to consume this PV resource, attach-detach controller is going to create a volume attachment resource, and this external attacher sidecar is going to watch for volume attachment resources, and it's going to call controller publish volume from the controller plugin, and then controller publish volume is actually going to make sure that this volume is attached to this particular node. So this is the thing that we have not implemented, but we were able to make sure that controller publish volume from controller plugin is being called by external attacher. So this is what we were able to achieve here. And to do that, we also had to deploy node plugin, and we had to deploy node plugin to make sure that CSINode resource is updated successfully, and our CSI plugin is actually registered with the kubelet that is running on the nodes. And this node plugin has two containers. One is obviously node-driver-registrar that calls NodeGetInfo from node plugin, and then registers this plugin with Kubelet. That is the reason we also had to implement NodeGetInfo from the Node plugin, and then we deployed this as Daemonset DA. Yeah, you know the spelling. I think, yeah, this is pretty much it that I wanted to talk about in this particular video. If you liked the video, if you think this is going to be helpful to your colleagues, classmates, share it with them. And yeah, I will see you in the next one. Thank you so much.